How many of you have a fully modeled character ready to go?
Almost.
Almost.
No.
Okay. So that's fine. Here's what I would say. Almost everybody has to do this whole process 2 or 3 times anyway. The first time you'll be like, why didn't that work? Or why did this mess up? And really, when it comes to rigging, like, it would take you more time to problem solve it than to just redo it. So what I would say to do is save whatever it is you've been working on and kind of follow along with steps of this. I'm recording the videos. They're currently recording. I'm broadcasting on Zoom so you can kind of follow along. There's other versions of the videos up on D2L. This is not something that you're going to completely understand flawlessly in this one class. But this is where I get to talk about it and where you get the chance to ask me questions about it as we're going through it. Right? So I'm going to rig my character today. Again, I think it's probably a good idea just to acknowledge where we are in the semester. Like, this is week 13, and I was going to just skip that, but I really want to be able to start talking about animation next week, because next week is really our last week of class. Right? After that, we have the final the week after that. Right? And then the semester is over, and you've got this class under your belt, and everything is okay, and you can finally get some rest. Having said that, I know that we're kind of snowballing, like, and you're probably freaking out a little bit because we only have those 3 weeks left, and there's all of this time off for Thanksgiving and all of that. This should be balanced out well enough to where you can get all of this done. Right? This is the right amount of time to be able to do it. Particularly if you've kind of been working along. Like, if you're like, oh yeah, I should probably start coming up with a concept for my character right now, that's probably not a good place to be. Like, you probably need to be further along than that. And hopefully you have at least a portion of your modeling started. But next week is almost entirely, like, we're going to have lots of time to work on stuff. I'm going to do the walk cycle demo. Then we'll have some lab time to be working on it. And then this isn't really due until halfway through finals week, right? Or, well, like on Thursday of finals week. So we got a decent amount of time to get this done. Don't stress too much. Stress the right amount, just like that medium amount. So I can... this is one of the reasons I do want to simplify this character, though, right? And so if you have a more complex character, that's cool. You are welcome to try some more complicated stuff on it. What I would say is to have a contingency plan, right? Like, if you model a character that also had arms and like an antenna and a giraffe neck, and like, is there a way you can simplify it to where if you can't get all of that done, you can get a scaled back version to this level? Okay, so before we jump in here and start rigging this character, we're going to talk about some other stuff really quick. And I'm just going to open up another version of Maya so I can tinker in there. What is that noise? Is that on my computer? Somebody raising their hand?
When I joined the Zoom.
Ah, I think you're right. Yes. There it is. So yeah, this is out there. Yep, we got 2 participants. It's just us 2. Okay, we're good. So yeah, if y'all want to follow along, that's cool. Okay, so what I have, what we're going to talk about first here is a different type of deformer. So we went over deformers a few class periods back when we were rigging our spoon, right? And you remember how we were putting in like a bend deformer or a twist deformer. And that works really well if you need a single deformation on an object, right? If you need a snake to crawl across the ground and you just need that wave or that sine deformer, that works great, right? If you need that snake to try to dance or something like that, that was really hard to get that to happen. With just those single deformers. And you probably recognize that by trying to animate your spoon. You probably tried to get it to do something like, oh, I want to have it sort of look around, And that was harder than you expected it to be, I'm sure, or harder than it really seems like it should have been. Yeah.
Is there your camera on?
On the oh, am I not? Oh, yes, I can. I'm sorry. I launched Zoom, but then I didn't set it up to have the camera projecting. So
Wait, what is all this stuff on the screen? It's not mine. And it said your camera's off.
camera's off. How do I? Now it's telling me I'm not in the meeting. Oh, wait, there I am. But nope, not the camera. Let me get this. How do I expand this back out? Ah. I will cancel. There we go. Share screen two. There we go. Did that work?
Nice.
Share.
Yeah, now.
There we go. All right. Thank you. I would have just sat here and. There's so many steps anymore to getting class started because you have to log into Zoom, it has to text you, you have to get all that. So, yeah, that's not bad. All right. So the other thing with those deformers is you probably thought about something more complex, like a human or a character, right? And like, if you use those deformers, you would have to really, like, that would get really complicated, right? Are you going to put a bend deformer for the elbow and the wrist? Like, what if the wrist needs to do something really complicated, right? So the answer is no. Those deformers are for more of a standalone type of deformation, right? You need a single type of deformation on an object. And there's a lot of different types of deformations too. If you need something to seem like it's sort of melting or completely morphing into a different shape, we would use something called a blend shape. What we're going to be using today, though, is a whole category of deformers, and they're not just deformers. It's really a hierarchy system. So I'm just going to show you how those work in this new version of Maya I have here. So I'll go to my top view just so we can kind of look at this in 2D space. So in the rigging tab, we're going to see a couple of menus here. There's skeleton, skin, and then deform, right? And deform is all of those other deformers we've used before, right? The clusters and the nonlinear deformers. Skeleton and skin kind of go hand in hand. These are two different elements of what we're going to be using to deform our character here. So if you think about how we are actually sort of structured, right? Anything that is a vertebrate, how do we say that? Has a skeleton inside of them. That's what kind of keeps helps us keep our form, right? That's why my arm doesn't flop around like a rubber hose everywhere, right? And so the other thing though is a skeleton has specific pivot points or hinge points, right? There are different types of joints and sockets that allow our bodies to kind of move around. So really what we're going to do is build a very simplified version of a skeleton for something that has more complex deformations, right? And so within the skeleton menu here, we see this like create joint, insert joint. Let's just create a joint and see what this does. So if I go to create joint, just to show you how this works, I'll also open up my outliner here. You'll see I get this like little locator here to create stuff. I'm just going to click a few times and show you how this works. So I click the first time. You'll probably see I get like a little bitty circle right there. You can kind of see that, a little sphere. Now if I click a second time out here, you'll see that it gives me another one that's connected to it. And if I go over here and look, these are the objects that are being created, joint 1 and joint 2. But the second time I clicked, it made the second joint a child of the first joint. And if I keep clicking, it's going to continue to do that. So really what I'm creating here is a hierarchical structure, or a hierarchy. Right? After I've clicked this a few times, I'm just going to hit Enter or W or whatever. And now I have this joint chain. It's kind of hard to see on that screen, isn't it? Let me see if, was it Control B? No. I'm trying to remember what the trying to remember how to change the background color. I don't remember right now. Let's just try hiding the grid. Maybe you can see it a little bit better that way. It is. It's a shortcut key for that. Let me fix real quick. Windows. Sorry. That's not it. Anyway, sorry. I was going to try to change the background colors, but I can't remember what the shortcut. Alt B? Is that
I
it?
thought it was Alt for the long. Oh, it is Alt.
It is Alt B. You just have to have that window selected. I tried that and I was like, why isn't that working? It's because mine had something over here selected instead. Let me see that better. Let's just try it like that for right now. Can you all see that better or worse?
Wait, what control is that?
Alt B. And so it just sort of like changes what it looks like in there. Let's try that. That's maybe a little better. Okay. So the interesting thing about this hierarchy is that a couple of things. If I were to put a light in here and render it, I would see absolutely nothing. These are invisible objects, right? In fact, you know how we could create groups? We did that earlier. A group is just like this invisible folder. And some level, you can think of these joints as just one of those folders that has a visible representation in here, right? And so you can kind of see this, right? Joint 1 is this top joint, and if I rotate that top joint, all of those other joints are going to go with it. Now, if I select joint 2, so I have the second one selected there, and rotate it, all of the joints underneath it go with it, right? So we've kind of talked about these hierarchy systems before. Now, if I were to grab the endpoint of this very last joint, joint 5, move it, rotate it, whatever, none of those others are affected, right? So you can kind of tell the parent to child relationship just with this visualization here. You have this top joint and then this sort of arrow pointing to its child, right? Which means we can create some pretty interesting joint structures if we wanted to. So again, I'll go to skeleton, create joint, and I can click here and here to get one, right? And hit enter, but then I can go back and do that again, skeleton, create joint, and I can select this joint as my starting point, and I can start making this other hierarchy that goes here, and then I can do that again, skeleton, create joint, start here, and make this whole other hierarchy, right? And so my hierarchy structure now is a little more complicated. I have this root joint that will rotate everything, But then after that, I got these other hierarchies that are kind of built on top of that, right? So this is what hierarchy is the word I think you need to kind of get into your mind and thinking about this. This is a parent-child relationship that the parent of a system is the thing that can sort of control all of the children of that parent and as grandchildren in theory. If you look at it that way, right? So joint 4, I select that. 5 and 6 are going to be affected by its change. Right? So this is how most systems kind of work, right? If you think of like a tree, right, with all these different branches. Well, if you cut down one limb, all of those, or even shake one limb, all of those smaller limbs that are sort of hooked to that are affected as well. That's sort of the same with our body, right? If you think of my torso as the sort of the root system, right? If my torso moves around, like my arms and my head have no choice, right? They have to go with it. If my shoulder moves, my elbow, my wrist, and all of my fingers have to go with it, right? I can't really make I can't make my index finger go above my head while the rest of my arm stays down here, right? Or not comfortably. So all of that is sort of how a lot of systems are built. And so this tool becomes super useful in rigging a lot of different things. But again, as it is right now, it's just a bunch of nodes. Like it's not going to render, it's not going to affect anything. If I put an object in here, like it's not going to affect it, it's not going to do anything to it. Right? It's just this thing that's floating in our scene for now. So I'm going to show you how to make it affect things. Let's start with a cylinder here. And let's go to our front view instead of our, wow, look at that. That cylinder is the same color as our background. It's a little easier to see. So I'm going to make this cylinder kind of tall. I'm actually going to make 2 versions of it. Control D. Move this over. And then the original one, I'm going to add some more subdivisions just so we can see how this works. So you can kind of see the difference. One of them is really just 1 polygon tall. Right? It's like 1 polygon all the way to the top. And we've seen before how this can be affected by a deformer, right? Because these vertices, if I try to deform them, I can never make this thing curve, right? So I need this level of resolution to be able to start getting deformations out of this. So that's all I'm really going to do right now is just to show you that. Let's go ahead and sort of zoom. Yeah, so it's back at our origin point here. So what I'm going to do is I'm going to put some joints inside of this. So I'm going to go to skeleton, create joints, and I'll hit 4 so we can see through it, and see that I can just sort of start clicking in here. If I hold shift, it will sort of lock it in sort of the up and down axis while I'm doing that. And I can just go through here and insert joints into this object. And when I hit enter, it just sort of highlights the whole hierarchy. But again, this is just two systems here. There's a model, and then there's a series of joints. Where this becomes powerful is I can turn that series of joints into a deformer. Now it's important to recognize that like the other deformers, like a bend tool, there was really no other use for that other than to be a deformer. There are other uses for joints other than to be a deformer, which means you don't have to make these deformers to still use them for other things. But in this case, I want them to deform an object. To do that, we have to skin the object. So that's what this second tab here is. So again, if we're sort of using the same analogy, joints or bones, right, are underneath our, at the sort of the core of our bodies, right? The skinning is sort of what holds all of that together and allows the the joint to deform that system as a system, right? So when we say skinning in Maya, though, what is really going to happen is we have these joints, and we're telling Maya that we want each of these joints to deform parts of this model, right? And the way that that deforms is sort of based off of like its distance away from those joint or from those vertices. But basically, each joint is affecting certain vertices, right? So let's sort of look and see what happens when we do that. If I select, so the way you make skinning work, you select the joint hierarchy. So I'm just going to select the top joint. You don't have to select all of them. And P cylinder 1. And then I'm going to go to skin. And it's this top one, bind skin. Now before I click that, I'm going to click the options box just so we can look at some of this. So we have 4 joints and we have a whole bunch of vertices. Right? When I skin this, what's going to happen is Maya's going to say each of these vertices are going to be deformed by one of those joints or one or more of those joints, right? And the percentage of which those vertices are affected could be different, right? So it could be that I completely want all of those vertices at the top to be controlled by a joint 4, the one that's all the way at the end, right? Or it could be that I want them to partially be controlled by joint 4 and partially be controlled by joint 3. So the way that Maya makes that decision is based off of these settings. So we're going to bind it to the joint hierarchy. So since I selected the top joint, it's going to bind it to all of those other joints below it as well. Right? If I just wanted it to bind to joint 1, I would change what bind to has in there. I think there's the option of doing selected joint or object hierarchy. My bind method, right here, this is where we can get some really interesting changes in how it assigns those weights. So right now I have it set to closest distance. So what that means is if there's a vertex, it's going to say that the joint that is closest to it in distance is the one that's going to affect it. Right? And once you get to some of these joints that are sort of like in between, it'll sort of distribute that kind of evenly. Right? Closest in hierarchy means the closest joint that is closest to it within that hierarchy, right? So if I were skinning 2 arms and they were side by side, but they each had a different hierarchy, it would try to skin it to the one that was in the same hierarchy, right? That way I'm not getting skin weight from my right arm on my left arm, right? So that's the one I'm actually going to probably use most of the time, but in this case it doesn't really matter. I want to point out these last 2, heat map and geodesic voxel. Both of those are sort of new methods. Geodesic voxel just sounds like something somebody made up, right? It's because they did. Heat map means it's going to sort of, it's the one that works the most accurately, but least frequently. So if you use heat map and it works, you usually get a really good result. But really probably 80% of the time it doesn't work at all. It just tells you that that mesh isn't a good fit for heat map weighting. There's reasons for that. And geodesic voxel does okay as well. So in this case, though, let's just do closest distance. A couple of other things to notice in here. Max influence. This is the number of joints that can affect each vertex. And so I don't want it to be infinite, just because that's the number of calculations will get kind of heavy. Usually 4 or 5 is pretty good. This is interesting for people who are considering doing video games. Most game engines only want 4, and so that means if you skin something to 5, when you export it, it'll trim out that extra object, right? So it affects your skinning a little bit. So that's the only reason to really pay attention to that section is if you ever plan on skinning something or rigging something for a game. So if I hit bind skin, it doesn't really look like much changed, except for all of these joints are a different color now. Makes it a little easier to see them, at least on my screen, probably not up there as much. But when I rotate these now, you're going to see that they affect the object. Right? And so now I've built sort of this ability to manipulate these joints and create a different pose on this cylinder. Okay, is this making sense? Kind of how this works? Okay. I don't like any of those. Let's try this one. So here's the problem with this, is that Maya made a whole bunch of decisions for us when we skinned it about which vertex to assign to which joint. And we can cross our fingers and hope that Maya made the right decision. It never completely makes the right decision. This is one of the reasons that I usually assign this as a robot, right? Is because it's a little easier to adjust this skinning afterwards if you don't have a whole bunch of interconnected pieces, right? Because I'll just sort of show you how this works. If I select the mesh and I right-click on it and go to Paint Skin Weights tool, what I get is this new tool that pops up here, and you'll see that each of our joints are listed in here that we skinned to, and you'll see that my model changed from whatever color it was before to a gradient of white and black, right? So what this means is, think of white and black as numbers, right? White is 1, black is 0, right? It's a value of white that you have applied to this, right? White, or if it's set to 1 or it's white, that means it is completely affected by the joint you have selected, right? So, and that makes sense, right? I have joint 1 selected, that's that first joint. All of this bottom half is completely influenced by just that joint, right? And if I were to go back here and rotate that, that makes sense. All of those vertices move when I rotate joint 1, but when I rotate joint 3, none of those vertices down there move, right? So if I go back to that again, Paint Skin Weights tool, as I step down here, you'll see, joint 2 is affecting this region, joint 3 affecting this region, right? And then joint 4 has just got a little bit of influence up here at the very tip of this, right? So if I were to take joint 4 and rotate that, just a little bit of that being influenced. Now, since this is a hierarchy, that means if I rotate joint 2, I'm also moving 3 and 4, so everything above that kind of goes with it, right? So that hierarchy still maintains because all of those other joints are moving with it. So really where this becomes complicated is if I just don't like how this transitions here. So if I go to my Paint Skin Weights tool, if I wanted to make that transition different, you'll see that the reason for that is these sections in the middle are kind of this light gray, right? And that means, like, instead of being affected either 1 or 0 amounts, right? They're being affected like 0.2 or 0.7 or 0.5, right? So what this Paint Skin Weights tool allows us to do is to paint and add or take away influence from certain joints. So joint 3, that's this one up here, right? If I wanted to tighten this bend up a little bit, what I would do is I would add a little bit more influence to those vertices on joint 3. So if you look at how this works, I can paint to add that influence, and I'm painting the value of 1. I'm painting white. So when I paint that, you'll see it messes it up. I'll Control Z. But if I go in here and paint just a little more influence right here, you'll see that that kind of changes the way that deformation happens and makes that a little tighter. If I go here to joint 2 and kind of do the same thing here, and so I'm kind of messing some stuff up there. If I hold down Shift, it will smooth it back out again. Okay? So these are actually all those same painting and sculpting tools that we used before. So B will adjust my brush size. So let me undo that a few steps until I get to that point where I didn't mess it up. Because I think the reason I messed that up is because my brush was a little too big and I painted over, right? So if I hold down B and move it from side to side, I can adjust my brush size. The other thing I can do is I can tell it I don't want it to paint 1. I want it to add a little bit. So like right now, if that value on joint 3, like on joint 2 right there, if that value is like 0.7, and I just want to add a little bit to make it influence it a little bit more, I could change my value to like 0.1 instead of 1. And then little bits at a time as I start painting right in there, it's going to add to it and sort of build that up, right? So that'll allow me to kind of more gingerly address that, right? Go back to joint 3, add that in there. So now I get a slightly different bend in that crease now, right? Now, why this? Well, again, I said that usually I advise you to do something that's a segmented model. And the reason for that is you have to do a little less of this if you do. So let me just sort of show you as an example. I'll create a quick segmented model here. If I go, something like this, Control D, that up, something like this. Right. So if this is the model, all right, and I go to my front view, let's do my left view, and I go in here and create a skeleton for this. Skeleton, create joints, click one there. So now when I skin these, I choose all these cubes, I choose those joints, skin, bind skin. I'm going to get some weird deformations in here, right? See, that's like kind of squashing that on this bottom half and this top half. But if I want to fix that, all I have to do is skin each of these objects individually. So paint my skin weights there. And what I'm wanting is for joint 5 to be the only joint that's influencing this bottom part. So I can just set this value to 1 and hit flood, and it will paint all of that object I have selected to a value of 1. Sort of the same with these other objects here. So paint skin weights. I want joint 6 to be the one that affects it. Flood that. And then sort of the same here if I'm getting this like sort of collapsing happening there. Paint skin weights. W. Try that again. Paint skin weights. That's joint 6. Flood that. And so now I have this hierarchy that I can quickly go through here and animate these joints to get that change. Right. Okay, I'm going to do one more thing here before we jump into actually rigging our robot, and I think it will also be pretty helpful. So when I used my myself as an example, right, and I was like, if I move my torso around, right, my arms and my head go with it. But the thing that you may have not been really paying attention to is that my feet don't. Right? My feet are staying stuck to the floor. But my feet still need a hierarchy. Right? My whole legs do, because I can sort of squat around, I can do whatever. My knees still need to bend. Right? And so that's where we get a concept that, let's work around. What did I do? Apparently not. Let me delete that really quick and do this from the front view. Skeleton, create joints. Just do it like that. So imagine this is sort of a leg scenario, right? And if I were just laying on the ground or flying through the air, right, it would make sense that I could sort of waggle my leg around and I get that motion, right? But really, most of the rest of the time when I'm standing on the ground, I need my foot to stay stuck to the ground, right? Now, any type of hierarchy that's going from the top down within a 3D package like this, that's usually the standard way we think of a hierarchy. It's that the parent has to rotate for the child to move, right? So, for example, I rotate my hip, my knee, and my foot goes with it, right? But that causes a lot of problems if what I need is my feet to stay stuck to the ground, right? If my hips go lower, then that means my feet would go to the ground. I need them to stay stuck in a place, which means I really need the end of the hierarchy to have some control. So whenever we have the hierarchy working the way it is here, where the parent is affecting the child, we call that forward kinematics, FK. Okay? This is a phrase that you'll hear me use a lot. Right? FK is how like my arms are moving right now. My shoulders are rotating, my arms are flying around, my hand is being affected by the parent, which is the shoulder. However, there are times when I need my hand to stay locked in place. If I grab a hold of this, right, my hand is locked in place, and that means the child is really controlling how this deformation happens, right? So since that's backwards in the hierarchy, we call that inverse kinematics. So these are the phrases that you'll hear, FK and IK. Okay? Okay. So we'll talk about that a lot more as we get into more complicated animation classes. Forward kinematics and inverse kinematics, though, inverse means it's working backwards than how you would think it should, right? And so what that means is I want my leg to stay stuck to the ground there, right? And so there's a tool in here under skeleton that allows us to do that. It's this IK handle. So by default, all joints are FK. What we're adding here is the ability for this joint system to be IK as well. So before I do that, I'm going to go to my options box because there's a couple of things I need to do. First, I need to make sure it's set to sticky. So click that little sticky point there. Right? Let me show you how to get to that. Skeleton, create IK handle, and then choose the little options box. So turn on sticky. And then I usually want to make sure that I'm using a rotate plane solver. There's another one that's called a single chain solver. Rotation plane solver means that there's an extra attribute in there that tells you, like in this case, which direction your knee is pointing, right? Otherwise, without that, you just get what you get. So this will help me a little bit to create that. So once I've clicked those buttons, you see I get the little crosshair again. I click the top hierarchy point of my IK, which is going to be the hip here. And then I click the ankle, and watch what happens. I get this little line that it draws in there. And so if I go in here to my perspective view where you can see this a little bit better, you'll see that you get this IK handle here, and a move tool is sort of at the bottom of this, right? In this whole system, if I select that point right there, I get this little move tool. The cool part about that is I can grab the ankle, like the IK handle that is at the ankle, and now I can move this around however I want to. Right? So I get this system. So when we clicked sticky, that was the really important part though, because that means I can also go up here and grab the character's hip, move it down, and the ankle will stay locked in place. Right? Does that make sense? So this is a really nice tool. And when we use it like this, it's pretty simple, kind of simple to see how that works. Now, there's a couple of things I will talk to you about as we're creating our rig for our character. One of the big things, though, is it creates this arrow right here. See that? And if you look in my IK handle, I get this option for twist. Basically, what Maya does is it looks at the angle in which that joint is bent. So if you create a perfectly straight line for your leg, it's not bent at all, and the IK won't work. So you have to put a little bend in it, and you put it in the direction that you want your character's leg to bend, right? And so that's why when I move this IK handle, you'll see that my knee constantly points in the direction of that arrow. Right? It doesn't really go flopping around anywhere. This twist is what allows me to kind of point the direction that knee is in. So I show you that because that's one of the things that people mess up quite a bit is that when they're creating their joints, they're not very clean about how they create them. And so let's say if I did this in the front view, I went skeleton, create joints, right? And I did something like this, but I kind of got this one off alignment a little bit. It's a little bit like something like this. So my knee isn't pointing straight forward. That means Maya's going to find the angle at which they all line up, and that's the direction it's going to bend it. So if I create an IK now with this, you'll see my character is kind of bow-legged, right? It kind of points outward at the knee, right? So all of these are things we kind of have to keep in mind. Okay, I've gone over a whole lot of theoretical stuff here, right? How we are eventually going to apply this to a character. Mainly so, like, I feel like understanding the inner mechanics of it or the inner workings of it allows you to sort of troubleshoot stuff when it comes your way. But I recognize I just threw a whole lot of stuff at you without examples or without actually implementing it into the rig. So what I'm going to do is I'm going to use all of that stuff that I just showed you to create the skeleton for our character or for my character. So your character may not be completely ready to rig yet. That's okay. You can start tinkering with this. Just save it as a new version as you're tinkering, and you can always go back to the model to fix it up and re-rig it again. Okay. So one of the things to pay attention to, if you look at my character from the front, the knees are pretty straight this way, but if you look at it from the left view, you see I got some bend in there. You'll also notice how I divided my character up. I get this question a lot. Should it all be one piece or should it be multiple pieces? Mine's multiple pieces. There's a lot of different thought behind why that is. Some people, if you're modeling something for games and it's a really complex object, but it's not going to deform, it's just a set piece like a chair or something like that, you just want to be able to import that one object as cleanly as possible. You also have to consider stuff like draw calls, like the number of times your graphics card has to process it. And so a lot of times in modeling, people want to combine all of their objects. They select all of them and go to mesh combine. Now, if you've done that already, it's all right. Not all is lost. Like I recommend not doing that. But when you do that, you'll see a couple of things. I only have one mesh now, but I have all of these pieces here that each represent those old parts of the model, right? And now if I selected the model and said edit, delete by type, history, all of those disappear. Now it's just one mesh, right? And we can skin it this way, but the problem is then I can't select individual parts and use that flood to fix my skin weighting. So if yours is in this state and you're like, oh man, I wish I wouldn't have combined it, that's okay. The easy way to fix it, or to undo that, is to select the model again, go to mesh, and then separate, the one right below combine. And look what it does. It seems to break it all up into these pieces. Now it keeps it in a group, right there, right? But then I can actually select all of those pieces of mesh and say edit, delete by type, history. See that little transform disappeared. And then I can pull them back out here and rename them. Now, I'm going to undo back to the point before I did that because one of the really important things to do at this stage, and I feel like I'm going to say this, and then internally, you all are going to kind of roll your eyes and be like, yeah, sure, I'm going to take time to do that. It's really important to go through and name everything. because you're going to get really confused. Rigging is probably the most like you can't hold all of this stuff in your head, right? It's not. We don't have that much bandwidth. People can only really memorize like 4 digits at a time, and eventually we're going to have a lot of stuff going on in the scene. So as much as it seems frustrating to stop and take time to do that, naming things as you go is crucial at this point. So I've got all of my objects named so I can see that's the right hip, that's the left hip, that's the right knee, that's the left knee. All of these are different parts, right? And then this is the floor, so we don't really need that. Okay, so what I'm going to do is I'm going to go ahead and start creating my skeleton for this, and I'm going to do that in an orthographic view. So let me show you why. Is if I go to rigging, skeleton, create joints, and just start clicking, like it's just going to create them everywhere, right? And if I go to my perspective view, see like it kind of sends them way off into the distance. Like if you just click in your perspective view, Maya has no idea what depth you're wanting to create that at, right? And so in this case, it's actually just creating it on the grid for me. So creating it in your perspective view just usually doesn't work. Also, if you model this cleanly enough, it's just going to make more sense to do it in one of your orthographic views. One of the things I like to do is I like to try to keep my model right there at the origin point, right, to where this line is sort of dividing the model in half. One of the ways you can do this is just model one leg at a time, duplicate them over to the other side for some symmetry. Or if you're modeling in symmetry, that works as well. I will show you just a quick little trick for those of you who are still in the modeling phase. Let's say you have this, you modeled this using symmetry, but this was like, I just modeled that one leg. There's a couple of ways you can get that across. If I select all of these, I think it's under modeling, mesh, and then this mirror. So I can choose, actually that doesn't work the best. Let's see. Oh, that should work, but I'll show you another way we can do it too. I can select all of these mesh pieces and hit Control D to duplicate all of them. And so instead of moving them over to mirror them, I can group them, Control G. And then my origin point for that group is right there at the center, right? And so if I go to my channel box for that group, of group 1, you'll see that all that's zeroed out, that's at the center. I can scale this to -1 and get a duplicate over it on the other side, right? So that's one of the other ways you can do that. Now, I guess that mirror tool, now that I'm thinking about that, that works better if you only modeled half of your object. Like if you only modeled this, then what you can do is that mesh and then mirror, and that mirrors that across. So, does that make sense? So, I'm sure you're all still kind of tinkering away with that. The biggest thing, before I do anything else on this rigging, I want to make sure that my model is prepared for it, right? I've done everything that I need to do. So similar to the spoon, I'm going to freeze transforms on all of this, and I'm going to delete history on all of this. So select all of my model, and then modify, freeze transformations, and then edit, delete by type, history. This is actually a really important step because if you don't do that, once you've skinned it, you may have a really complicated rig ready to go. Once you skin it, it's going to deform it incorrectly. Okay, so those 2 steps are really important. Freeze transformations, delete your history, and now we're ready to start putting joints in. So, yes?
Can we still texture it out?
Yes.
Is it
So
like a simple color texture?
Here's what I would say to do. If you're just adding a solid color, you can pretty much do that anytime, because you're not really going to have to worry about stretching. You may have to worry about texture stretching if you haven't UV unwrapped it. So you can still do anything you want to in terms of texturing, but you want to have your UVs laid out before you before you do the skinning. So you can start creating the joints. Just don't skin it until you UV unwrapped it first. Because what will happen is this deformation we're going to add to it will happen on top of the UV unwrapping, and so your textures will kind of slide around on your model. So usually that's why you would want to UV unwrap it first and then delete the history. Also, deleting your history means that your models are simpler, like it's taking less information to calculate it. And so a lot of times people won't delete their history, and then by the time they get to animating, they're like, why is Maya going so slow? It's because you're asking it to calculate every one of those extrusions you did, right? If you delete history, it wipes all of that out of the calculation, calculates it a little more simply. So, so it's just a really important step before we go on any further. So, okay, I'm going to go ahead and start creating the skeleton. And I like to do this in an orthographic view. Actually, I almost have to do this in an orthographic view. So I'll go to the left view. Here. And I'm going to do it from this view because I need to make sure I'm getting that bend in the knee. Right? And this profile view really tells me a lot about this leg. So I'm going to go again to rigging, skeleton, create joint. Now the first joint I'm going to create is the sort of the parent to everything. Like this is, we call it the root joint. Right? This is the one that will control everything underneath it in terms of a hierarchy. Of course, we can put the IK in it, but that's still the root, right? And so in any character, usually that's its center of gravity. For most bipedal characters, that's usually located somewhere in like your pelvis, belly button region. And you realize that because that's what shifts around when I'm moving, right? That part of my body moving affects almost everything else in my entire body. Now my feet are connected to the ground, but if I were flying through the air, it's still my center of gravity that gravity and all the physics forces are affecting. My legs would be dangling behind me, right? They're not really the parent of that. So usually I try to think, where is this character, like where would this character wear its belt, right? That's kind of what I think of, right? And so I'm going to say somewhere around here. Keep in mind, this is also how the character is going to like turn its head and sort of lean forward and back. So this is the pivot point for that as well, right? So I like right about there. If I'm thinking of this as a head, this is about where the neck joint would connect into, right? So maybe somewhere like right about there. I'll hit 4 so we can kind of see that joint. So that's our root joint. Every other joint that we create is going to be for a pivot point that we need for deformation on this character, right? So like the next one is our hip joint. Where do I want my character's hip to rotate from, right? And that's where I'm going to put that joint. So I would think it would be right about there. So this is like this little cushiony padding thing I create in here. So I'll click right about there. That's my second joint. I know it's kind of hard for you to see it. That's not helping. Maybe it helps a little bit. My next joint is for the knee. Like where do I want the knee to deform? Where do I want the knee to bend? And so I'll put it right about there. And I'll just sort of keep going. My ankle joint, I'm going to put it sort of right between these two pieces of mesh right here. The next thing is like I don't really need a heel joint in this case because my heel isn't going to bend. And this is like a deformer. This is what is going to rotate to generate some deformation. Right? So my next one would be sort of the ball toe point right here. So like where you would roll up on your toe if you're walking, like you sort of roll up on your ball of your foot with your toes. So I'll click right there. And then this last joint actually isn't necessary for deformation, but it is very important in terms of being able to see how that deformation will work. So this is almost more like a visualization joint, so I can see what the deformation is doing. So I'll click this last one out here, Usually I will call that like toe end or toe or something like that. It's just so I can see what the character is doing, right? And I hit enter. You'll see now I get this hierarchy through the whole character. Now, unfortunately, if I go to my perspective view, it didn't put it in the right place, right? It put my root in the right place. I want my root right on 0, 0, 0, right? What it didn't do is put the leg in the right place. So I can shift that over from one side to the other. But I want to be careful on how I do it, right? So if I hit W, I don't want to just grab and just sort of sling it over here and try to find it, right? I recognize I drew it perfectly in the side, so really all that needs to change is my x-axis. What we're trying to do is keep as clean of numbers as possible over here. You're never going to be able to keep it all zeros and ones, but you'll be able to get it as close as possible. So if I only have to affect one axis, I can sort of move this over in the front view so I can see how that lines up. Kind of lining up with everything. And you see all of that works pretty good, right? Now, as much as it's really tempting to just go ahead and start making the next leg, I'm going to do some house cleaning first. So like I said, naming stuff is really important. And so, like, which joint is joint for? Is that the knee or is that the ankle? Think about it. You'd have to count down, right? And so, like, I don't want you to have to process all of that. Like, there's a phrase I like, which is recall takes less energy, less time than thought, right? So really what we're doing by naming this stuff is making us not have to think, hey, wait, which joint is that again? It takes a little time. It's worth doing it. Also, you need to recognize when naming stuff that this is a symmetrical character. So if there's a hip, there's also going to be another hip on the other side. So I want to say, is this the left hip or the right hip? Ideally, most people think of this as the character's left or right, not like if you're looking at it from the front, it's on your left or right. So like, which of these legs would the character think of as their right leg? And it's the one that we've created here. So I'll name these joint 1, R-O-O-T, root. Joint 2, I'm going to name that R underscore hip. And I'll just kind of step down and do that with all of them, right? R underscore knee. R underscore ankle. R underscore ball. And then R underscore toe. What did I just do? I did it wrong. R underscore toe. Okay? So, if you take the time to do this, it saves you a lot of headache in another way too, which is I can just generate my other leg. Okay? Since I modeled this as symmetrically as I could and tried to make the center point like on this x-axis here, if I select that leg and go up here to skeleton, there's a mirror joints option. So I'm going to choose the options box in there. And so this is a little confusing at first, like mirror across. So really what I look is like, which direction do I want it to go? And if I see my little axis down here in the bottom corner, I'm wanting it to go in the x-axis, right? So I look for the one that doesn't have x in it, because that means I'm mirroring it across the other two axes. Right? A way to think of this is if we were mirroring it across this piece of paper, right? That means we look at the direction that is sort of perpendicular to that piece of paper. It's mirroring it across those other two axes that make up this piece of paper, right? It's mirroring it over to here. So right now that's going to be Y and Z for me because I'm trying to mirror it across the x-axis. So here's where this is really handy to have named these already. I'm duplicating the leg to move it to the other side. So rather than just duplicating it and then going back and renaming all of them, I can have it do a search and replace. That's why I did the R underscore, is because that's a little easier to find. If I just had it replace R, then any of these were like root, it would change it to loot, right? So the other thing to recognize is I'm not mirroring everything. I'm not mirroring the root over. I'm starting with the R hip. I don't need 2 roots, I need 2 hips. So I'm going to search for R underscore, replace that with L underscore, and then I'll hit mirror. And now I have 2 sets of legs. Okay. Am I going too fast?
Can you explain that one more time?
Which part? The mirror part or all of it?
Yeah, well, I mean, that's just the mirror part.
Just the mirror part?
Yeah.
So, I selected the R hip,
Okay.
right? Skeleton, mirror joints, and then the options box. So, figuring out, in all honesty, you can always just do it a couple of times and figure out which of this, like, if you choose the wrong one, worst case scenario, it mirrors it across the wrong axis, you hit Control Z, right? But really what I look at is the direction it's going to be going in the world, right? And so this little thing down here in the bottom corner, it's going to be going in the x-axis. It's going to be mirroring over to the x-axis. So if it's mirroring to the x-axis, that means I want to choose the option that doesn't have x in it. It's going to be mirroring across that plane that is not the x-axis. So I know that makes that maybe is a little confusing to think of.
Well, wouldn't it just be easier to copy and paste the?
Well, you could. Let's try that and see. So I can do that. Control C, or let's do Control D because I don't like Control C, Control V. So Control D makes a whole other leg. All of them are still here, right? They all have the R name in it, and then I have to make sure I get it perfectly in the same place over here. So really the only way to get it perfect would be to go over here and look and see what the number is on this leg, and its translate X, it is 2358. So that means in this one over here, I would want to make it, I'm sorry, it's the wrong number. It would be the 1707. So that means over here, I would want to do negative 1707 to get it in the same, negative 1, why is that not working? Negative 1.707, right?
I'm sorry, you don't have to.
No. So you can do it that way, but just recognize that the reason I did the mirror is so it would automatically generate all of that stuff for me.
Okay.
Because right now all I'm doing is just selecting that joint, skeleton, mirror joints, and then if I do this R underscore L underscore, it'll mirror it across my x-axis and get it there. Now, if you do move it and get it into that place, that's fine, but that's just the way of kind of getting it. But yes.
If you mirrored it and it's with it, is there a way to delete the root not really?
Yes, actually. So let's say you accidentally selected the wrong thing. You mirrored the root instead of R hip. So really, that just depends on which one you have selected.
Yeah, it got everything, but just it took the root.
Yeah. So if you select root, and I did that mirror, I'll show you what happens here. So now I have 2 roots that are like each separated, right? Which means there's not really a parent for either of them. And so really what we want is we want to be able to grab that one root and control the entire character's hips. But right now, since there's 2 of them, like there's 2 sets of hips, right? So if you did that and like you find that out later on, really the easiest way to fix that is just to grab this L hip, middle mouse drag it onto the original root, and then just delete that duplicate root. Because then everything is parented under root. Or just hit Control Z and remirror it with the hip selected instead. Okay. Questions? Okay, so why this is, I wish you could see that thing. That's such a bad, like, is that any better? You know what'll help? Let me get rid of this sky dome too. Control H. And I'll also hide this floor plane. Maybe that's a little better. Can't tell.
Can you just turn on X-ray for the joints? And do it in like full object mode?
That might work. So yeah, shading. We can get a shading and say X-ray joints. And so now if I hit 6, can you see that a little bit better? Maybe a little bit. All right. So we can see that a little bit better. Basically, that means it's going to allow the joints to show through even if there's a model on top of them. So, yes.
Just hard to another question, but the root, how do you move it without moving the rest of the? It's like all connected, so when I move the root, it moves very well.
So if you, let's say you, that's actually a good question just in general about joints. Let's say I didn't like where I have my knee here, but I don't, if I move my knee, right, it affects the ankle and everything else, right? If I just need to reposition that, what I usually use is insert. If you use the insert key, it'll allow you to move that joint by itself. So the same would be true of the root. If I select the root, then I can sort of reposition it to where I want it. Other questions? Okay. This seems like a good place for me to save because this is where we're going to get into some more complicated stuff. So, file, save scene as, I'm going to call this bot rigging class. Save as, continue. Okay. I think it's just like we were. Let me think about this. So I'm going to show you the skinning part of this first. Recognize this is not the point in this process that you have to do the skinning. You can do the complete rig and then skin it after that if you want to. I'm going to do it at this step just so you can see how it's affecting the model as I do the rigging. Does that make sense? So like I want to be able to show you like it's a little easier for demonstration purposes if this model is actually skinned to these joints. Recognize if you skin it, you're unhappy with something, you can always unskin it, make changes to the model, and then reskin it. You just have to redo the skin weights when you do that. So to skin my robot to all of these joints, I just need to choose my root joint and all of these up here. So I'm just holding Control and selecting all of my pieces of mesh. And then I'm going to go to Skin, Bind Skin, and I'm going to choose my options box. So again, I'm going to use joint hierarchy because I've clicked the root joint, but I really wanted to skin it to everything in here, right? The next one, though, is how do I want to bind this? And so if I use closest distance right now, recognize that this ankle is closer to this ankle than this knee is, right? So that means that this ankle may end up getting skinned to this ankle joint instead of this knee joint, right? Which is kind of not what I want, right? Or that lower part of the leg, not the ankle. So if I use, instead of closest distance, if I use closest in hierarchy, I usually get a little bit of a better result. So I'm going to go ahead and hit Bind Skin. And now what I should be able to do is just test this out and see what I get out of it, right? So if I select this joint, I rotate it. Okay. So first, the head is really messing up, but the ankles are not doing anything super crazy, right? I'm actually okay with that. The knee, if I do that, yeah, so that's actually feeling correct. So I get panicked emails every semester because people are like, I'm moving my character's leg and his head is disappearing. What is happening? Like, this is normal. This is what happens when you ask a computer to make creative decisions, right? It does it wrong. So one of the big things to remember is I can wiggle this stuff around, but I always want to get it back to how it was when I created it. So I'm going to hit Control Z, get that leg back down, because this is called our bind pose. This was the position that all of those joints were in and that the model was in when I skinned it. Right? And that's going to be important to be able to get back to that point to reskin it if anything messes up. Lots of reasons that this is important. So to fix some of these things, I'm going to do some work on the skinning, right? So I'll select this head part, right click, paint skin weight tools, and I want the root joint to be the only thing that's really affecting all of that. So I can just set my value to 1, select root, hit flood, and now you'll see that when I rotate that leg, the head is maintaining its shape. Now the eyes are warping all over the place, and so is that little grill thing on top. So I can always go back to those, right click, paint skin weights, root, flood, W, paint skin weights, root, flood. And so I'm just going to do this with all of these to make sure that they kind of stay the same, right? Now the other little thing you may be noticing here, these are really small things, but like when I bend my character's knee, I'm getting some kind of neat deformation on that little rubber gasket thing in the middle. But you'll see that the leg is sort of bending right there, and that should be like a piece of metal, right? The other thing you may be noticing is, maybe not that as much. Let's see if I do it here. Yeah, if I bend the character's foot, like look what kind of happens to the heel. It kind of squashes and stuff, right? Now, if I'm wanting this to feel like a solid piece, I would just not want that to happen. Those little rubber gasket pieces, I'm okay with those warping and bending. But the solid pieces, I want those to retain their shape. So what I'm going to do is just kind of go through there in each of those, paint skin weights. And this is where naming stuff becomes really handy. This is where I can find right hip instead of joint 32, right? And joint 32 is not going to make any sense to you. So right hip, flood, and I fixed it. There we go, do that again, paint skin weights. Right knee, want all of that to be affected, flood. So, paint skin weights, this is all going to be affected by that ankle joint. And then this is all going to be affected by the ball joint, which is right there. So really, again, this toe joint isn't distorting anything. I just want to be able to see it. So when I rotate the ball, I can see what it affects. Wait, what did I just do? Apparently I did the wrong thing. That goes to R ball, not R ankle. Flood. There we go. So if you have more detailed stuff you have to paint, you can still use the paint skin weights tool. Right on my knee here, if I wanted my knee to affect this little gasket more, I can paint more of that in there, right? All of that is stuff that we can control. Just right now, I'm just sort of affecting the hard parts of it, right? So paint skin weights, left hip, flood, W, paint skin weights, knee, flood. And so now, I'm sorry.
No, you're good.
So now when I start editing this thing, it's deforming the way I want it to. Right? I'm getting that deformation on those little gaskets here. getting sort of that deformation, but the model itself is sort of retaining its shape. Another good place to save. File, increment and save. Okay, so I have a model. Yes.
How did you get your, so the rubber gasket thing that you feel like still sticking, but at the beginning you was, you kind of advise against combining stuff, so if we have like multiple parts of our leg, how do you want us to, cause like whenever I've had my knee joint, it kind of sticks that, like I have like a kneecap part, so it kind of like sticks it in the same place instead of moving it along with my other parts.
Yeah. So that if you're wanting that kneecap to sort of be distributed between two pieces, then what you would want is to have half of it flooded and the other half to like flood half of it to one joint and half of it to the other, right? So right now my paint skin weights, mine's different because like I want it to warp. If you're wanting yours to kind of float, maybe one of the ways you could do it is instead of flooding a value of 1 to the knee and the hip, I would flood a value of like 0.5. So I could flood half of it to the knee, half of it to the hip, and so then when I distort this, it'll kind of stay halfway between the two. Right? Not necessarily how it. Oh.
Nice.
So sometimes this happens when you start undoing skin weights. What I'm going to do is unbind skin on that knee, and then I'm just going to rebind it again to that whole thing. Skin, bind weights. So that still works. So there's another thing. Like let's say the reason that I don't really combine it is because like even if I had let's say like let's say that this was like a bolt or a screw, right? That is on the side of my character's leg. So if I wanted to keep that in that place, that just means that the weighting on this object has to be the same as the weighting on this object. So if I were to skin all of that, skin, bind skin, you'll see that right now, if I slide this around, it sort of slides on the model just a little bit, it sort of changes shapes. It's really subtle. But as long as I go in here and say paint skin weights and flood that whole thing to the knee, wait, 1, not 0.5. Then it's going to go with it everywhere my leg does. Okay? Does that make sense? Maybe it's awfully quiet. Awfully quiet usually means no, that did not make sense. Okay, so here's what I would say. It's a lot, like, and it's a lot to like process too. The other thing is we're not even nearly done yet. Because what we so yeah, I know. Give me a bit. It's okay to get lost in this. Like it really is. I don't think I've ever had anybody who like at the end of the lecture was like, "All right, save it. I'm done with my rig." That's really not how this works, right? Just like it wouldn't work that way for me to animate, and you have a finished animation by the time I'm done showing you, right? It's going to take you kind of going back and going through this step by step. That's why I record it. That's why I have multiple versions of this recording. And I would say the other thing that's a little different is everybody's models are different. Everybody in the class has a different robot or creature that they made. So it's going to take a couple extra steps. Just sort of follow through with the videos, and I will be in here on Tuesday and Thursday of next week to help you with any little hiccups you're having. Okay, the reason we're not nearly done yet, so like, I mean, sort of back up. If you're feeling, what happened to the other toe? What are you doing? That's not right.
That's all right.
Not right. Flood. A value of 1. I do not know what that thing thinks it's doing. Alright. It's misbehaving. Okay. So, the other thing is, I just don't get overwhelmed by this. I know it sounds overwhelming. Like, you are not the first class to come through here. And, like, the vast majority of people get through this, okay?
The vast majority.
The vast majority, right? Like, that's really the best you can hope for. The vast majority of people don't die from food poisoning, right? So, like, you'll get through it, and it's okay to eat at most restaurants in Jonesville. I can tell you if you do not, but I'm not on camera. So, yes.
It's very impressive, Mr. Boyle. You're stressing her out more.
Well, you're not going to die from poisoning
Yeah.
either. You're okay.
This model. Like, what?
Okay, so it's okay. So don't sweat it too much. You'll get through it. The way to get through it is to model or to sort of go through it step by step, a little bit at a time. But what we have here is really the same thing we had when we put that bend deformer in the spoon, right? We have a deformer that is deforming our character correctly. What we don't have is a user interface that allows an animator to get a good animation out of this, right? And that user interface is just called a rig, right? This is not a rig, this is a deformer. So all of these joints, all of this IK that we're going to add to it, all of those things are just elements that help us get the right deformation. A rig is something that we can set up that makes an animator's life easier. And since you're also the animator, that's something you want. So that's what the rest of this is. I'm going to walk you through rigging the character's hips or root, right? And one leg, and we will stop there, and you can kind of have some more work time in class and have time over the next couple of days after Thanksgiving, to kind of work through this and get the details ironed out. So, don't worry, we can get through this. We got this. File, save scene. Okay. So, the real problem with this, first, is that if I wanted my character to bounce up and down, I could grab this root, and the character's bouncing up and down, but if we have that floor visible, right, the character is going through the floor, right? So I need those feet to stay in place. How do we do that again? Remember?
It was IK, right?
IK.
Oh my god.
Skeleton. Create IK handle. Again, just to make sure we get our options box. I want to make sure sticky is turned on and make sure it's a rotation plane solver. And then I'm just going to do 2 clicks. I'm going to click on the character's hips or hip and then the character's ankle. So now what I get is this little IK handle. I will call this R leg IK. R leg. And then if I grab that and move that around, my character can do quite a bit with its leg, right? So we're already getting a little bit more of a usable puppet, right? And the other thing is if I grab my character's hips, that foot will stay in place. The toe's still kind of going to the floor though, right? So I'm going to show you sort of the way we'll fix that here in a minute. But let's go ahead and just make that other IK really quick, just so I have it. Skeleton, create IK, hip, ankle. So now they both kind of stay stuck to the floor, all right? Yeah, this is, like, I can't tell you, like, how often, like, once you get this rigged, I'll find people just being like, like, it's okay. It's like a rite of passage. Like, okay, so.
He does it with the complicated one.
It's one of these, like, it's kind kind of the fun. Like, that's why we got into this, right? Because we all had our G.I. Joe or our, like, She-Ra or whatever it was. And we were like, God, get your Skeletor. And then you were like, we're all doing that, right? That's why we got into this. And surely He-Man did get Skeletor in the end. So it's okay. Like this is kind of the fun part of it. We're going to get to move our character around. We're going to get to move the thing that we've been making around. So again, like I'm wanting to make this as simple as possible, though. Like right now, the reason this character is hard to animate is because there's too many things I have to select in order to get my character into a pose. So remember that discussion post we had about poses? Right. Oh, you know what? That just reminded me. Do we have a discussion post this week?
Yes. Oh wait, no, we don't. You said happy Thanksgiving.
Did I?
Yeah.
Okay, cool. That's what I meant to do. I was worried I didn't. So that's good to know. Way to go, me from a couple of months ago.
Self-five.
Self-5, exactly. Okay. I am going to try to get this character down to 3 controls that I have to animate. Okay? That's 1 for the root and 1 for each foot. Okay? And those 3 controls, I should be able to get every pose I need out of this in order to animate the character. I'm not really going to try. I'm going to do it. I've done this enough. I know how it's going to work out. Recognize though that that is a decision-making process, right? There's a lot of people, it's how you want to interact with the rig that makes that, a valuable skill. Right? A good rigging artist is somebody who works with an animator, finds out how that animator wants to work on this, how they want to animate, and makes a tool that person can animate efficiently, right? So for me, those 3 controls means I don't have to key as many things, I don't have to keep track of as many things, and I think I can get all of the flexibility, like dexterity, out of this character that I need with those 3 controls. So I'm just going to start creating some NURB circles. I'm just going to start with 1. So this is, I'll rename it, this will be my root CTRL. No, that's an S. C. Root control, right? It sounds like something you would spray in your garden. Root control. Destroy those annoying roots. So I have this control, right? And I want this control to be able to control this joint, right? I want it to be able to make this happen, right? Which like that, it doesn't look right, but like this, it makes a little more sense, right? So that means I want them to align to each other. There's a couple of ways we can do this, and I'm going to show you both of them. The first thing that, you probably have already found this, but this show menu is really nice because the reason I like it is because it allows me to hide entire categories of objects at once, right? So right now, the things that are kind of getting in my way are all of the models. Now, obviously, I could put those in a layer and just hide them, right? But since all of these models are polygons, I can also just uncheck that, and all of the polygons disappear for a minute, right? They're still there, they're just not visible in this viewport. So if I want to align this, there's a couple of ways I can do that. I can actually just hold V. V will allow it to snap to points. And so that's one of the reasons I hit my model is because I don't want it snapping to all the vertices. But now if I move this, you'll see it snaps to each of those joints. So that's V as in Victor, Virginia, villain. Now there's another way I can make this happen too. And this is actually kind of new in Maya. Under Modify, there's this Match Transformations tool. Or all of these tools. And so I can match translations, rotations, scaling, any of that. So if I select this object and then select my root and hit Match Translation, it just snaps it up there to where it's in the same location. Right? So that's really handy. The problem with it is after scaling it, rotating it, all of that stuff, let's go bring it back. After doing all of that stuff, now my channels are ugly. Right? I got a lot of values in there I don't need anymore. Right? I got that, it's 6.06 in the scale. I've got these translation values I don't want. And so how do I get rid of those again? Freeze transformations. Modify, freeze transformations. So now that's pretty clear. I got a little bit of stuff in here I want to get rid of, so I can also do edit, delete by type history. And so now that control is pretty clean, right? All right. Sometimes, so I'm going to open up a new version of Maya to show you some stuff. Do I already have two of them open? I do. Like I planned ahead or something, which I did not. But box, circle, cylinder. There we go. So we have these three objects, right? And we've talked before about parenting things, right? If I wanted that box to go everywhere that the sphere goes, I can take that P cube, middle mouse drag it on top of P sphere, and now it's a child of P sphere. Right? And so if I select P sphere and move it around, that box will go with it anywhere, but I can still move this box, right? The problem with that is it requires me to change the hierarchy of objects, right? And sometimes that hierarchy is important for other reasons, like because they're in a because they're skinned or they're in a joint, or maybe I need more than one object to affect an object, right? So for those, we're going to use constraints. So those are different. So in the rigging menu, you'll see constrain right here. There's people on the outside. And so constraints are going to work very similar. It allows one object's values to control another object's values. So if I go to, let's break this off so you can kind of see it. So watch what happens here. If I select this sphere, and then I hold shift and select this cube, and I choose parent constraint, look what I get. So my cube now has these blue channels on all the translates and rotates, right? Also, my cube has this little node underneath it, this parent constraint. But I didn't have to change the hierarchy of any of those objects. And if I grab the sphere, the first object I selected, and move it, that cube will go with it. More importantly, if I wanted to try to have both of these objects partially affect this cube, I could grab the cylinder and the cube and add another parent constraint to it, and now this will half affect it and this half affects it. Right? So constraints are really nice, but there's a lot of different kinds of constraints. So one of them is that parent constraint, and that's going to work just like if I parented an object under another object. There's also a point constraint. So a point constraint is going to look like make the cube disappear. It didn't. It put it inside of the sphere. Right? So what a point constraint does is it says the translates of object A controls the translates of object B. Undo that. An orient constraint is sort of the same thing as a point constraint except for rotation. So if I choose orient, you'll see that the rotations of this sphere will control the rotations of this cube, right? Which is interesting to see happen because they're not like right on top of each other, right? So the problem with this is it's a direct connection with no offset. So if I select this object, I select this cube, I do a point constraint, it's going to snap it to the same location as the sphere, right? Well, I don't always want that. Sometimes I want to maintain that offset. So if I go to point and choose my options box, you'll see that there is, thankfully, a button to maintain the offset. And so when I hit add, now what I have is this will, whenever I move this object, the cube will move in that direction. But if I rotate the object, the cube is not affected. So this is a lot of different tools you can use in order to have one object control another object or be constrained to another object. So because I don't want to go messing around with that skeletal hierarchy, I'm going to use constraints instead of parenting. So let's go with this. I have this control. I want it to control the translates and rotates of this root joint. So which of those constraints do you think I should use? We have parent, point, orient. Parent? I'm going to go with parent. Parent is right, actually. So I select the circle, select the joint, parent. And so now, if I move this, that control will control that joint and will control the rotation of it as well. Which means I don't actually even have to be able to see the skeleton anymore. If I hit the skeleton, like I can animate that and it just works, right? And that's actually how we're going to eventually end up working on this. Now, obviously, it can't all be that easy, right? There's a couple of extra steps for something like a foot. So I'm going to show you two different ways to do the foot. I'm going to show you the easy way. If I show you the easy way to rig it, though, you should probably assume that that means it's going to cause some complications. Like it's easy for a reason, right? It's because it doesn't have as many controls to control the foot. And then I'll show you the hard way as well. So the hard way gives you a little bit more control over what the foot does. So again, I'm going to create a control for each of these. Go ahead and scale that up. I'll just do the match transfer. Modify, and I'll match my translations on that. I'll duplicate it. Match translations. Select both of them. Modify, freeze transformations, edit, delete by type history. And then I'll name them something that makes sense. We'll call this one R leg CTRL. And then this one is L leg CTRL. Okay. So the easy way goes like this. I showed you those other two constraints because they have a purpose, right? In this case, I don't want this control to just be changing the translates and rotates of one object. I want it to change the translates of my IK and the rotates of my joint. So you'll kind of see why that is. If I select this and just choose the IK and go to constrain and do a point constraint, then that's actually going to work out pretty well for the location of this ankle, right? If I move that control, now it goes wherever I want it to. The problem with that is that the foot is still just pointing in whatever direction it wants to, right? And I don't want that. I want to be able to control the rotation of the foot. So if I select that control, hold shift and select the joint, not the IK, and do an orient constraint and say maintain offset. Now when I move this control, that foot will stay in the orientation I want it. So this is always something that confuses people, so I'm going to back up a few and show you that one more time. A few more steps back apparently. There we go. So again, step one, I want to unhide these polygons so you can see it. Whoa. Okay. Step one, and there is an order to the direction you need to select these. You select the control first, and then the IK handle. It's kind of hard to see the IK handle there because my arrow is there, so I can hit Q to hide that. Or I can select the IK handle over here if I want to. So I select the control first, hold down shift, select the IK handle, and then that's a point constraint. So that allows my leg to move, right? again, deselect everything, select the control, select the foot, and do an orient constraint. And so now my foot is pretty much completed. So that's the simple version of the foot control. There's still one piece missing to this, and that's that toe. Right? And since the toe really just has to move in one direction, it seems silly to make a whole new control for it. So what I like to do is I like to make a couple of attributes on this control. So I'll go to Modify, Add Attributes, and I'll do toe. And then just because I know it won't be too hard, I'm also going to add one in there called knee. And so now I have a toe and a knee control on this ankle, right? So for that, we're just going to do that direct connection just like we did with the spoon. Windows, General Editor, Connection Editor. And so for the toe, I want this toe attribute to drive this joint, and it's the rotate Z that I want it to control. You can see that because if I adjust this, that Z gets values in it. So I'll select that joint, reload toe, and then I find my rotates in here, which is usually minimized, so rotate Z. And so now I have this control, and that toe value will control the toe. Now the other thing I like to do is, remember when we were talking about this arrow that points forward? That controls the direction of the knee, right? And that's what this twist value will do, right? And so rather than having to dig around in there and find that IK and adjust that twist, I like to add that to this control too. So I'll reload left. I don't really need two of the knees there. I'll select the IK, reload right. I'm going to go down here until I find twist there. So knee, twist, close. So that's the simple version of the leg rig. That means if I grab this control, and actually I'm just going to turn off joints just so you can see that this works without the joints. We don't even need to see the joints. I grab this control, like the foot will stay planted on the ground, and at any time I want to wiggle the toe, I can. Anytime I want to point the knee, I can. Now there is a problem with this rig, and there's a reason that's a little simpler. Like we really haven't done anything in there that we didn't do on that spoon, right? We just made a couple of direct connections. The problem with that is, in order to make our character take a step, right? If you look at what your foot does when you step, you usually roll up on your toe like this, right? So in order to get that pose for my character when he's taking a step or she's taking a step, I have to get this in here so you can see it. I have to pick my character's foot up a little bit, rotate it down until that part is touching the ground, and then roll the toe up a little bit, right? And that's a little annoying to be able to get that pose. It also means that it's going to make your feet slide around a little bit when you're animating it if you're not really careful. So I'm going to undo all that, and I'm going to show you the more complicated leg. Now, not everybody will need this more complicated leg, but this will give you an automatic foot roll option. It's just going to be confusing how it happens. I would say this is one of those things that just sort of, if this is something you need, just sort of follow the steps and don't try to wrap your brain around it just yet. After you've done it a few times, it'll kind of make sense why it works. But I'll still show you as we go. A lot of this is still the same, right? I still need this to control some stuff. It's actually been a little while since I've done this, so I may mess it up a little bit at first. Sort of bear with me. So first things first is I need this to control the ankle, or the calf, right? But I really need to be able to control that by rotating at this point of the ball of the foot. So I'm going to actually create another IK in here. So if I go to skeleton, create an IK handle. Actually, let me name my other IK so I don't get confused. This is L leg IK. So for this one, if I want to put that IK in there, I'm going to create skeleton, create IK handle, click from here to here, and I'm going to call this R ball IK. Okay. So this is interesting. With this IK handle, I just connected it from that joint to that joint, right? So it's going to work differently. If I grab that IK handle and move it, it's just going to rotate my ankle when I move it. Okay? So that seems confusing at first, but just trust me. Like basically that means the endpoint that I have here is going to select where that foot is aimed. Okay? So this is where we can kind of play some pivot point tricks on this. If I have to think about this here. Yeah. So this IK, I'm going to select it, and then I'm just going to put it in a group by itself. Control G. So now what I've really done is I've changed the pivot point for that entire group of IK. Right? So if I rotate it from here, now it's going to pivot from over there. So let's call this ball IK group. So what I'm going to do is I'm going to change this pivot point to be back here at the same spot that this IK is. Show. And I'm going to hide my model just so we can see that happen. So again, hit Insert, or D will work as well. And then if I hold down V, it'll allow me to snap it to that joint. And so now when I rotate that, it doesn't look like anything's really changed. But that's because this joint right here is still holding that end in place, right? Or this IK is. So really what I have is this IK is holding that part of the ball, or that part of the joint in place. This IK is holding that part of the joint in place. So I'm going to select, there's probably two different ways I could do this. Let's try this and see if this works. So if I middle click and drag this R leg IK under my ball IK group, when I rotate that now, I get that. So that works. I could also probably do it as a constraint if I wanted to. But I'm going to go ahead and leave it like that for now. Let's see if this works. So the last part of this is that, like, really now this group has both of those IK systems in it. And so now that group controls my entire leg. You can see how that kind of deforms around when I move that. So really that means I just need this control to control this ball group, right? This may be where I'm messing up. Yeah, no, it's not. So what I'm going to do is I'm going to drag this ball group underneath this control, this right leg control. So middle click, drag that in there. And so if you look at the hierarchy now, it looks like that. There's the leg control, the ball group, there's two IKs underneath it. So that means if I grab that control and move it around, my whole leg moves, but I still have this ball group that allows me to rotate up on that ball. Okay. So I'll show you again what that looks like with the model. If I grab this control, I can move the character around, move the foot around, I can rotate it, but this ball group still allows me to roll up onto the toe. And so what that means is if I need my character to take that step forward, I can grab that ball group and roll up onto the toe, and then I could counter rotate that toe back up here to fix it. So pretty much we're in the same spot. It's just a little bit more of a complicated hierarchy to get to there, right? And so the way I'm going to do that is I'm going to go ahead and add those two controls that I need to this again. Actually, in this case, I'm going to need three. I'm going to need the knee, the toe, and the ball. Right? I'm probably going to do them in the other order of that, though, ball, knee, and toe. So I'm going to go to modify, add attribute, ball, add, ball. I'm actually going to do ball, toe, knee. Toe, add, knee. So back to our attribute editor, or I'm sorry, back to our connection editor, Windows, general editor, connection editor. So I need this control, reload left, that ball, toe, knee. And so now I'm just going to connect those up the same way I did over here earlier. My ball group, reload that right. It's the rotate X that needs to change for that. So ball connects to rotate X. Toe, I need that to line up with this toe joint and its rotate Z. So I'll select that toe joint, reload right, toe, rotate Z. And again, this IK, that twist control, reload right, knee connects to twist. Okay, I know I lost probably everybody there. The trick to that again is to watch that again in slow motion, like watch it on 0.5 speed as you're working through it. Because what I have now is a really nice setup for this. And the cool thing is everything except for the model and all of these joints, I can hide, right? I can like literally take all of this junk right here and put this in a layer. I'll call that layer do not touch rigging. Right? People will do that sometimes just so people don't go messing around in these folders and mess stuff up. There's actually a couple of IKs that are still kind of hanging out in here that you can see, those two. So I'll add those in there as well. That work? There we go. Okay. And then the other thing I usually do is I select all of the model, like all of the mesh pieces. We could actually do that up here, probably easier. Add those to a layer, and then I freeze it so I don't accidentally touch it. And so now everything I need to animate are in those three controls, right? And I can set keyframes on those three controls because of all of that extra work I went through to get whatever pose I need out of this character. To sort of show you how that new foot works, so if I rotate up on the ball, the toe kind of goes through the floor, but then I can just counter rotate that toe, right? Now the cool thing you'll notice though is if I rotate both of those at the same time, if I highlight ball and toe at the same time and middle mouse click out here, it just rolls up on the toe. Right? As long as those two values are the same, it'll just rotate up on the toe. And then the toe value is if like I need a little bit of extra wiggle on it or anything. And of course my knee will allow me to aim it. So this is a better foot rig because that allows me to keep my foot locked in one place and still roll up on the toe so it doesn't feel like your foot's sliding around on the ground as they're walking. So really what I'll probably do for the piece I'm going to animate next class period is I will create one of the rigs that has that rig for both feet. Right now, the thing for you to watch out for, every foot in this class is different, I'm confident. Some of you may just have like a spike, right, that's like digging into the ground. If so, that means you probably don't need that ball or toe or any of that stuff, right? Some of you may have a backwards pointing knee, right? Like a horse's back leg kind of does that. Let me look that up and sort of show you. Or a dog's leg. Really? It's just a whole bunch of videos of dogs on leg braces. It's actually really adorable. Let me find a good, yeah, here we go. So, open image tab. So your leg may look something like this, right, where it feels like the knee actually points backwards. Recognize that that's not really a backwards pointing knee. Really, it's the same thing as if you were walking on a tiptoe and your foot was really long. Right? That's really what's going on there. This is the ball. This is the ankle or the heel, right? And then that's the knee, and then that's the hip, right? So whatever you're doing, like your character is probably going to be completely different. It's probably going to require a little different rigging, right? Next class period, I'm going to go through the walk cycle process, and I can give you some feedback as you're working on your rig. But the walk cycle process, I'm not going to spend the whole class on it. It won't take as long as this did. And it's also one that I really kind of go over more of the principles than anything, so you can animate it the way you want to. But there's some important elements of that that are consistent throughout everybody's walk. So there should be time over the next week for me to help you troubleshoot your rig, troubleshoot your animations. In fact, we have a little bit of time today. It's 1:39. If you have questions, I can hang around till the end of class. We'll hang around till the end of class. Otherwise, questions first out loud. Any major questions? Project. Okay. Yes.
Do we absolutely have to have a texture? Can we just mess around with hypershade? We get a look that we like.
I would say, yeah, hypershade is fine. Here's what I would say. If you look in the rubric for it, I think there's a category for lighting and rendering and overall presentation. I'm not really checking off like technical attributes of that. I'm like, they use 3 textures, correct, right? It's like I'm doing the aesthetic check of it. Like, does it look good? And if you make it look good with absolutely no textures at all, that's cool. If you make it look good because you use lots of texturing, that's cool. The gradable part does it look good. so that would be the target. Yeah. So. And that kind of goes with everything. Really, if your rig is different, but you're able to get the manipulation out of it you need, the only real technical thing I count is the number of steps, and that's because otherwise, like, I've had people turn in like 2 steps, and I'm like, well, that's not really a cycle. It's just 2 steps.
Does it have to come to a stop, or can it literally just be a cycle?
Yeah. Yes. So what I'm going to show you how to do is, there's 2 different phrases there. We'll talk about that a little bit more on Tuesday. A cycle is something that looks exactly the same at the end of the animation as it did at the beginning. Ours isn't technically a cycle because I want the character to walk forward, not walk in place like a treadmill. But you can have it cycle infinitely and just like walk off the screen or do whatever you want to. The example I'm going to do is from stopped to stopped. So the character will be like standing in place, they'll start walking, take 6 steps, come to a stop. If what you want to do is have your character walking at the beginning of that and they just walk forward and walk past the camera off screen, that's fine. Or if they're still walking when you stop. Yeah, so any of that's fine. So, other questions, project? Okay. How many of you feel just a little bit behind on this project? How many of you feel a lot behind on this project? All right.
I want to die.
It's all right. No, I want you to live. Like, this is important.
I honestly feel like really good about the animated part, just not good about the modeling part.
That's all right. So, again, like, everybody's going to have the thing that they run with. I think that this is going to be fun for everybody, like, on some level. Everybody's going to have that part they liked, and everybody's going to have that part that they hated. I'm probably willing to put some money down on the part that more of you will hate than anything is the rigging. But there'll be a couple of people who'll be like, I love the rigging, that was so cool. And it is sort of like a necessary evil. I will say though, like, I feel like don't be too scared. This project is not the same scope as the last project. This is a little bit of a smaller project. It's just a little bit deeper, right? Like we delve deeper into different topics. Having said that, there's no effects in this. If you decide you want to put effects in yours, feel free. Like you can add whatever it is you're really enjoying. If you want to put a cape on your character, go for it. Other questions, comments, concerns, conundrums, complications? C is for cookie. Alright. So the rest of the class is yours. I'm going to go ahead and stop the video. I'll upload it to YouTube, and then if you have questions, sort of last minute questions, I'll hop around and help you out however I can. Cool.